Hello. So today we are going to solve this problem, minimum element in sorted and rotated array. Okay. So in this question, what we have given, we are going to be given a array. Okay. This is the array which we are going to be given. This is the sample input and this is a sample output one. So we have to find the minimum element in this array. So this is 5, 4, 5, 1, 2, 3. So we have to find the minimum element in this. Okay, so how can we do that? Okay, so this is the sample input. Okay, and what we can do here. Okay, so what we can do, first of all, let's think from a very brute force approach. Okay, so very brute force approach will be very simple. We are going to create a variable. Okay, so that variable we are naming this as min. Okay, and it is going to be initially it is going to be a very high number. Okay, so basically int dot max. So initially it is going to be very high number. Okay, and slowly we are going to change it. Okay, so initially it is very high number. Now we are going to run a loop. Okay, from here to here. Okay, so when our loop is going to be at the array of 0, which means 4. Okay, so we are going to check. Okay, is 4 less than our minimum? Okay, and if it is, then what we are going to do? So of course, initially our minimum is very high number, integer dot max. Okay, so of course 4 is going to be less than minimum, so it is correct. So what we are going to do, we are going to assign the 4 in minimum. So now minimum is not going to be integer dot max. Okay, it is going to be 4. Okay, now in the next we are going to be here. Okay, so 5. So we are again going to check, is 5 less than 4, which is minimum right now? Okay, so no, it is not correct, so we are not going to do anything. Okay, now we are going to be here at 1. Okay, so again we are going to check that is 1 less than our minimum is basically 4. So is 1 less than 4? So yes, it is correct. Okay, so what we are going to do, we are going to change the value of minimum by 4 to 1. So now it is not going to be 4, it is going to be 1. Okay, now we are going to be here at 2. Okay, so again we are going to check that is 2 less than 1. So no, it is not. So we are not going to do anything. Now we are going to come at 3, and again we are going to check, is 3 less than 1? So no, it is not. So we are not going to do anything. So after we have completed our the for loop, after we have completed our iteration from array 0 to n minus 1, what we have minimum as 1. Okay, so our answer is going to be minimum as 1. So our answer is going to be 1, and you can see as well that 1 is the lowest number in this whole array. So this is the brute force approach which we are going to follow for first. Now let's write the code for it. Then let's see that if we are correct or not. Okay, so what we have to do, we will create a int min, and initially it is going to be integer dot max value. Okay, initially it is going to be a very huge number, and then we are going to run a loop. Okay, loop is going to be 0 to n minus 1. Increase it, and at every instance, what we are going to do, we are going to check that if array of I is less than min, then what we are going to do, if it is true, then min is going to be array of I. And at last, what we have to do, we are just going to return our min. That's all we are going to do. So let's compile this code. Let's run this code. Yes, our sample test cases are getting passed. So let's submit this. Let's see that all the test cases are getting passed or not. Okay, we have some error. Possibly you could, okay. Okay, sorry. I have to do less than. Okay, so as you can see that all the test cases are getting passed. Okay, and this is the brute force approach. But of course, this is not a very optimal approach, because if you scroll down here, and then you can see that expected time complexity is log of n. Okay, and expected space complexity is also log of n. So basically, the time complexity of this solution is not log of n. Okay, and the time complexity is basically big O of n, because we are running a loop, and loop is going to take so much time. Big of n basically. Okay, so mm, and this is the problem. Okay, so what we have to do. Okay, so what we have to do, we are again on our Excali tab. Okay. Now, the method which we are going to follow is basically a binary search type of thing. Okay, because it is specifically mentioned that it is going to be a sorted and rotated array. Okay, so this is 4 5 1 2 3. Okay, so if I write 4 5 1 2 3, so this array is sorted and rotated. Okay, so what is sorted? Sorted is basically if I write this same array like this, so this is sorted. Okay, this is sorted. So what they did, they took this part of the array. Okay, they took this part of the array and put it right here. Okay, and this is sorted and rotated array. Okay, so we have to come up with a solution by which we are going to solve this in log of n. Okay, so how can we do that? Okay, so one answer is the binary search. So in binary search, what we do, we are going to take a low, and we are going to take a high. Okay, low is basically 0 and high is n minus 1. Okay, and then we are going to calculate a mean, mid. Okay, now we are if what how we are going to calculate the mid. So basically low plus high divided by 2, so 0. Okay, plus n minus 1, n minus is 1 is basically 4. Okay, so 4 divided by 2. Okay, so how it is, what number it is going to be? It is going to be 2. Okay, so mid is going to be 2. Okay, so at the second index, 0 1 2, so this is the second index. Okay, so we are going to check that if our mid element is smaller than its left neighbor. Okay, so if our mid element, basically array of mid is smaller than array of mid minus 1. If it is true, then this is our answer. Okay, how? Let's just check. See, if our mid comes to be here, okay, then array of mid is not less than array of mid minus 1. Mid minus 1 is basically this. Okay, so this second is not less than it. Okay, and if it comes to be here mid, then left is going to be this. So 5 is not less than 4. Okay, so the only way array of mid is going to be less than array of mid minus 1 if that is the lowest number. Okay, if array of mid comes to be here at 1, then array of mid minus 1 is going to be 5. Okay, so array of mid is going to be less than array of mid minus 1. Okay, so this is the one condition which we are going to look for. Okay, and if this condition does not get satisfied, what then? Okay, so in that case we will have two conditions. Okay, so let's look at that. The first condition is going to be if array of mid is higher than array of high. So this is high. Okay, and if let's just say mid is coming here. Okay, and this is low. Okay, this is low, this is high, and this is mid. Okay, if array of mid is higher than high. Okay, if array of mid is higher than high, so let's just say our mid is not here. Sorry for that. If mid is here. Okay, mid is here. So if array of mid is higher than high, okay, so 5 is basically uh, higher than 3. So this is correct. Okay, so if array of mid is higher than high, then what we are going to do, we are going to shift our low. Okay, we are going to shift our low, because if see here 5 is higher than high, so where are we are going to find the minimum element? We are not going to find the minimum element in this block. Okay, we are going to find the minimum element in this block only. Okay, so we are going to shift our low from here, from 4 to 1. So now our low is going to be here. Okay, and now we are going to do our search operation here. Okay, so low is going to be 2, and high is 4. Okay, and if I divide by this by 2, basically in this operation, then I'm going to get 3. So 3 is our mid, and we are going to look into this. Okay, now if 2 is 2 is not satisfying any condition. Okay, what was our first condition? But first condition was that array of mid should be less than array of mid minus 1. If in that condition gets satisfied, then our we got our answer. But is it satisfying that condition? No, 2 is not less than 1. So it is not satisfying our first condition. What was our second condition? Second condition was that array of mid should be if array of mid is higher than array of high, then we are going to do the subsetting. So 2 is not higher than 3 as well. So the second condition is also not satisfied. Okay, so what we are going to do if both the conditions are not satisfied? We are going to shift our high. Okay, we are going to shift high from so basically if both of the condition is not satisfied, then we are not going to find our answer in this block. Okay, we are not going to find our answer in this block. Okay, we are going to find our answer in this block only. Okay, this is the only block where we are going to find our answer. Okay, so this is how we are going to take this, and this is how we are going to solve it. So let's look at the code of this. Okay, um, wait a second. No. Let's look at the code of this. I'm going to write the code of it. So I'm removing it. I'm writing the code of our basically binary search. So First of all, what I'm going to do, I'm going to do int high. High is going to be nothing but n minus 1. Okay, I'm going to do int low. Low is going to be nothing but 0. Okay, and int, and now we are going to make a function for it. Okay, so let's see it solve. Okay, what it will take, it will take a array, it will take a array, it will take high. Okay, it will take low. Okay, and now what we are going to do, we are going to run a while loop. Okay, we are going to run a while loop, and while loop is going to run till low is less than or equal to high. Okay, and now we are going to calculate the mid. Okay, so mid is very simple. It is going to be low plus high divided by 2. This is very simple. Okay, now if our mid is okay, let's for a moment let's forget this. Okay, if array of mid is less than array of mid minus 1, then what does this mean? This means we got our answer. So we got our answer. So what we are going to do, we are going to just return array of mid. Fine. Else we have second condition. So if array of mid is basically greater than array of high, which we discussed. So what we are going to do, we are going to shift our low. Low is going to be mid plus 1. If both the conditions are not satisfied, then just write the else condition. Else we are going to shift our high, mid minus 1. Okay, so we are going to set our high. So this is the this is the way to do this. And at last, if nothing is going to be returned, then we are just going to return -1. Now there are some catches here. There are some catches here. In the initially what we have to do, we have to write a condition, and that condition is if array of low, this is the edge case. Okay, if this is to manage a edge case. So if array of low is less than or equal to array of high, then what we are going to do, we are just going to return array of low. That's it. Why this condition? Because see, let me just remove all of this, clear all of this, and I will tell you why this is the condition. Okay, so here we have basically 4 5 1 2 3, which is sorted and rotated. If instead of this we have a array something like this, okay, then it is sorted but it is not rotated. If array of low is less than array of high, then it is very obvious that array of low is the minimum element. Okay, in a sorted and rotated array of low is never going to be less than array of high. Okay, if this is not the condition, then we are going to do all the action. But if this is the condition, okay, if array is not sorted, then why do we need to why do we need to do all of this? Okay, we can just return array of low. One more edge case is array of mid is less than array of mid minus 1. Okay, so here one edge case can come up. Okay, what edge case? That edge case can be if, let's just say, array of mid is here. Mid is here. Okay, mid is basically 0. Okay, then what is going to happen? It is going to check that is array of mid is less than array of mid minus 1. So it will check array of 0, and it will check array of 0 minus 1, which is minus 1, which is a wrong thing. Okay, this is completely wrong thing, and it will give us error, because array of minus 1 is basically it will throw error that index auto bound. Okay, so we have to take care of this. So to take care of this, what we can do, we can just write here that if our array of low is greater than 0. Okay, if array of low is greater than 0, then just run this. Okay, oh, sorry, if mid is greater than 0, not array of, if mid is greater than 0 and array of mid is less than array of mid minus 1, then return our answer. Okay, so these are the two edge cases which you can take care of, and then let's just compile this. Missing return a statement. Okay, okay, sorry, I have not written anything here. So what we are going to do is just return it and just call this function and pass all the argument here. So high and low. Okay, now let's just run this. Okay, sample test cases are getting passed. Let's just submit this and let's just see that all the test cases are getting passed or not. Okay, so all the test cases are getting passed, and this is the way you can solve this. And the time complexity of this question is basically, if we are solving through binary search, it is big O of log n. Okay, big O of log n, and the space complexity is nothing. Okay, so we fill all the requirement of this question. Okay, thank you so much.